So this is the third in a series of videos to help you with the number sequence pattern. The first two in the series were arithmetic sequences and geometric sequences, and this is going to be something else. You can see that this sequence isn't an arithmetic sequence because it doesn't go up by the same amount every time, but it's also not a geometric sequence because if you try multiplying by something to get the next term, it's not the same thing you multiply to get the next term either. So I'm just going to look at the differences between the terms. So the difference between 1 and 4 is 3, so you have to go plus 3 to get to the next one. Then to get from 4 to 9 you have to go plus 5. To get from 9 to 16 you have to go plus 7. So it looks like the differences themselves are increasing by 2 every time. So if we look at the differences between the differences, so 3 plus 2 makes 5, 5 plus 2 makes 7, it looks like they're going to be 2 every time. So I'm going to call those the difference between the terms, and then the second difference, which is a piece of terminology that you can use. So write down in words any patterns that you observe. So we can write the second difference between the terms, if you like, i.e. the differences between the differences. Differences between the differences is always 2. Now, it's a fact that if the second difference of a sequence is constant like that, then the rule for it can be written as a quadratic. So these are all going to be about quadratic rules. So you remember quadratics, something involving x squared, or in this case, because we're talking about n, the rule will always be something involving n squared as the highest power. So having thought about the differences, let's think about what if the rule was just simply n squared. Then just get rid of that. So n squared, well, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and in fact on this occasion the rule is just n squared. So having the second difference being 2 gave you a rule of n squared, and you can take it as a general rule that whatever the second difference is, if you halve that second difference, so half of 2 is 1, then that's the amount of n squared that's going to be in the final rule. So because half of 2 is 1, we've got 1n squared, which is just n squared. Now there might be some other terms involved, like something with an n and something with a number on the end, but the bit that's got n squared in it, just take the second difference, halve it, and then that's how many n squared you're going to have in your final rule. So anyway, predict the next 4 terms in the sequence. Okay, well, let's just fill that in. 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64. I could have done that from my rule, or I could have done that from my differences. So if I hadn't actually spotted the rule, I could have gone, okay, well, the differences are going 3, 5, 7, 9, 11. I've just deleted something I didn't want to delete, haven't I? 9, 54, 13, 15. So without knowing that the rule was n squared, I could have done it from the differences between the differences always being 2. So the differences are going up by 2 every time. So you've just got to add on those numbers to each term to get the next one. 36 plus 13 gives you 49. So I've predicted then the next 4 terms in the sequence. So that's just filling in the table for some easy marks. Find a general rule connecting p and n. So I've already done that. P equals n squared. So it's got to be something equal to something else. You can't just write down n squared. You'll lose marks for that. Test your rule. So remember, testing and verifying is making sure that your rule works. When they ask you to test, they are asking you to check it for the numbers that are already in the table where they gave you both ones. And when they ask you to verify it, they're asking you to make sure that it still works for the higher values where you filled in some of the table. Okay, I'm just going to get rid of some of my mess here and make things a little bit tidier. There we go. That'll do. Okay, so test your rule. So I'm going to do it, for example, when n equals 3. When n equals 3, my rule says p equals n squared equals 3 squared, which is 9. And, oh, it is 9. So this matches the value in the table. So you could well be getting a mark just for that observation. So it's important to always have that observation. And again, the structure of the question is exactly the same as it was in the first 2 videos, where it was for arithmetic sequences and geometric sequences. Okay, so that's for n equals 3. I could do it for n equals 4. So just change some of these. So easy cut and paste here. When n equals 4, my rule says p equals 4 squared, which is 16, and that matches the value in the table. So that was testing, doing it for the ones that are already given to you. And verifying is just doing the exact same thing, but for some of the higher values, where you filled in the table yourself with your own predictions, and checking that it still works. So for example, 7, when n equals 7, my rule says p equals n squared, which is p equals 7 squared, which is 49, and that matches my value in the table. Okay, so that was fairly straightforward. Going to go on to a trickier example now. So write down in words any patterns that you observe. That could just be the numbers are all even in that case, and it can be something as simple as that gets you the mark. So let's have a look at what's going on here. It's not a geometric sequence or an arithmetic sequence, but let's just look at the differences. So 8 plus 16 would give you 26. 26 plus 28 would give you 54. 54 plus, gosh, I'm struggling to do this in my head right now, 38, is that right? Got a feeling I've done something stupid. Oh no, I know. 8 plus 18 gives you 26. Yeah, so you can see that the amount they're increasing by is increasing by 10 every time. So 10, 10, and so on. So the first difference is are 18, 28, 38, and then the second difference appears to consistently be 10. So you could actually write that down as a pattern that you observe in words. The differences between the differences, or in fact you can just use the correct terminology there, the second differences between terms are always 10. But the key to that is that it's got to be in words, in plain language, and avoiding any sort of algebraic notation or terminology. Okay, predict the next 4 terms in the sequence. So without even having figured out the rule, I'm spotting that the differences are going up by 10 every time. So the differences should be going 48, 58, 68, 78, so that the differences between them are 10 every time. And knowing that, I can predict the subsequent terms in the sequence. So 92 plus 48 is 140. 140 plus 58 is 198. 198 plus 68 is 266. And 266 plus 78 is 344, I hope, doing it quickly in my head. So see table for that one. Okay, so here's going to be the tricky thing. Find a general rule connecting P and N. Well, I mentioned in the previous example that the second differences give you a clue to the amount of n squared. So the fact that the second differences are 10 every time tells you that the rule is going to have a 5n squared somewhere in it. So let's just clear some of the mess I made there to give myself a bit of space. So let's just try 5n squared and see what happens. So 5 times 1 squared is 5. 5 times 2 squared, remember you've got to do the squared first. So that's 5 times 4, which is 20. 5 times 3 squared, so 5 times 9 is 45. 5 times 4 squared, so that's 5 times 16, which is 80. So we're not getting the numbers that we want, but let's just see what we need to do to get to those numbers. So we're getting 5, we want 8, so we're short by 3. We're getting 20, but we want 26, we're short by 6. We're getting 45, we want 54, we're short by 9. We're getting 80, we want 92, we're short by 12. And you can see a pattern to the numbers 3, 6, 9, 12. They're going up by 3 every time. So because they're going up by 3 every time the 1 or the n goes up by 1, then the rule for that must involve 3 times n. So in fact on this occasion they are just 3 times n. So the general rule that we want is 5n squared plus 3n plus 3 times n, and then that'll give us the 5 plus 3 is 8, 20 plus 6 is 26, 45 plus 50 plus 9 is 54. It's giving us the numbers we want. So find a general rule connecting P and N. P equals, on this occasion, 5n squared plus 3n. So now we've got the test and verify bit. So remember, test is for low values down in the bottom end of the table where they gave you the n and the p, and verify is checking that it still works for the values higher up in the table where you filled in the answers. So I'll just do a couple of these on this occasion. So test your rule, let's say when n equals 3, what's happened there? My rule says p equals 5n squared plus 3n. So that would be 5 times 3 squared plus 3 times 3. I might put those in brackets, even though that's not strictly speaking needed, just to make it a bit clearer. So equals 5 times 9 plus 3 times 3 equals 45 plus 9 equals 54, and 54 matches the value in the table, so this matches the value in the table. Okay, so that's testing it, doing it for a low value where you knew the answer because it was given to you. Now let's do verifying, which is just exactly the same thing but for a higher value. So let's do it for 7, for example, and see if we get 266 as expected. So I'll just delete all the 3s and replace them with 7s. Delete, 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 delete that lot, delete that, delete those, delete. Okay, so when n equals 7, my rule says p equals 5n squared plus 3n, so that will be 5 times 7 squared plus 3 times 7, which will be 5 times 49 plus 3 times 7. So 5 times 49 is 245. So it'll be 245 plus 21, which will be 266. This matches the value in the table. Okay, so that's marks in the bag for that one. Okay, another example. 0, 10, 24, 42. So exactly the same structure of question. Write down in words any patterns that you observe. The numbers are all even. Counting 0 as an even number. Predict the next 4 terms in the sequence. Well, let's look at differences again. So they're going 10, 14, 18. Okay, so the differences between the differences are 4 every time. So we can predict that this is going to go plus 10, plus 14, plus 18, plus 22, plus 26, plus 30, plus 34, so that the differences between the differences are 4 every time. And then we can start trying to figure out the terms themselves. So 42 plus another 22 would make the next one 64. 64 plus another 26 would make the next one 90. 90 plus another 30 would make the next one 120. And 120 plus 34 would make the next one 154. So predict the next 4 terms in the sequence. I've just done that. See table. Find a general rule connecting p and n. So I've observed that the second difference is, oh, by the way, I could write down any patterns that you observe. The second differences are all always all 4. So the fact that they are always 4 gives us the big fat hairy clue about the n squared term. So because they're 4, then half of 4 is 2. That tells us that our general rule is going to have a 2 n squared. So the amount of n squared in the rule is always half of the second difference. So if the rule was just 2n squared, you'd have 2 times 1 squared, which is 2 times 1, which is 2. 2 times 2 squared, which is 2 times 4, which is 8. 2 times 3 squared, which is 2 times 9, which is 18. 2 times 4 squared, which is 2 times 16, which is 32. 2 times 5 squared, which is 2 times 25, which is 50, and so on. So we're not getting the terms that we want, but let's just see what we need to do to the terms we're getting to get the terms we want. So first of all, we got a 2 when we wanted a 0, so we'd need to do minus 2 to that. Then we get an 8 when we want a 10, so we'd need to add 4 to that, so plus 4. Then we get an 18 when we need a 24, so we'd need to add 6 to that. What have I just done? Add 6 to that. Then we get a 32 when we want a 42, so we'd need to add 10 to that. I've just realized my mistake, that 8 plus 2 makes 10, not plus 4, so I'll just fix that. There we go. Then we get a 50 when we want a 64, so we'd have to add 14 to that. So the numbers we're trying to get, or what we're missing from the numbers we're trying to get, is going up by 4 every time. So that gives us a clue that we need to do something that involves 4 times n, because these are going up 4 times as fast as the n's are going up. So let's try involving 4 times n now. So let's just get rid of all that other stuff. So 4 times n. Well, 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. I'll just, there we go. 4 times 4 is 16. 4 times 5 is 20. So if we had 2n squared plus 4n, we'd be getting 6, 16, 30, 48, 70, but we're actually getting 0, 10, or we actually want 0, 10, 24, 42, 64, which is 6 less than the ones we're getting. So all we need to do now is take away 6 from the ones we've been getting, and we get the ones that we want. So the general rule is 2n squared plus 4n minus 6. So we need to write that as a rule connecting p and n. So that's got to have p equals something with n, and on this occasion 2n squared plus 4n plus 6. Looks like a difficult rule that's complicated to get, but it's just a question of picking out all the clues and then breaking it down. Test your rule. Okay, so we're familiar with test and verify. So it's just checking that your rule works for the numbers that are in the table. Just going to get rid of all this mess, I think, now. Okay, so when n equals, so when you're testing it, you're making sure that it works for one of the values that they've already given you. I'd go for one of the higher ones. So when n equals 3, sometimes the mark schemes do specify that it has to be beyond a certain point. So I always go for one of the higher ones if you can. When n equals 3, my rule says p equals 2n squared plus 4n minus 6. So that would be 2 times 3 squared plus 4 times 3 minus 6. I might just stick some brackets around things there to make them a bit clearer, although they're strictly speaking not necessary. So that's 2 times 9 plus 12 minus 6 equals 18 plus 12 minus 6, which is 24. When n equals 3, my rule says I should be getting 24 and matches the value in the table. What a relief. So always make the observation, this matches the value in the table. Okay, so that's testing it, and verifying it is doing almost exactly the same thing, but just for one of the values higher up. When n equals 7, so I'm going to get rid of all of the 3s I had before and swap them out for 7s. Okay, when n equals 7, my rule says that p equals 2 times 7 squared, which is 2 times 49, which is 98, plus 4 times 7, which is 28, plus 28, minus 6. So 98 plus 28 minus 6. 98 plus 28 is, 126. And then minus 6 makes 120. Okay, so that was part 3 of this. Part 4 to follow.